So hi everyone. We have question here of romantic glasses from CodeForces around 918, and I found this question very interesting to be honest, for because it was first time for me to do this type of question, which I will not actually. I was going to say which type of question was it, but let's just get into it and I'll explain what this actually uses and what's the intuition behind it. That's the main part. So let's understand the question first. Lulia has n glasses arranged in line. The ayat glass has AI units of juice in it. Lulia drinks only from odd number of glasses while a date drinks only from even number of glasses. To impress her date, okay, Lulia wants to find a contiguous array of glasses such that both Lulia and her date will have same amount of juice in total if glasses in sub-array are considered. Please help her to do that. More formally, this condition, which says the same explanation for this condition. I'll just explain the question. In input format, we have number of test cases and size of array and the array itself. We have given that sum does not exceed over this, so it will be done in 1 second, right? So I'll just explain the question. What the question essentially says that we have an array, let's say array of glasses essentially, and we have n glasses here. Let's go with one based indexing just for sake of explaining the question, right? And we have n here. So what the question says is actually Julia would drink from what's it odd number of glasses while a date drinks from even number of glasses. So what it essentially says, from odd glasses like this and this 5 red ones would be drink by Lulia and her date would drink from even glasses, right? So basically what we have to do, what Lulia wants to do is find a sub array, a portion in an array where both of Lulia and her date drinks the same amount of drink exactly. So what she essentially wants to do is find a sub array such that the odd basically the odd liters of drink equals to even uh I'll just write it precisely. What we want is to find drinks in odd number of glasses in sub array equals to drink in even glasses of a sub array. To do this, let's think, as we can use the formal definition as well. Let's just say L and R, like to find the subarray. This is a subarray which has leftmost index as L and rightmost index as R, right? This is leftmost and rightmost index. So what we have to do is find such L and R which would satisfy this condition, and if it does satisfy the condition, we would output our answer in yes or no, right? So how would you think about it? If someone goes the brute force approach, he would just check the sum in odd numbers here and here, and just keep checking the sum and just keep checking the sum. That would almost take a lot of time, which isn't quite feasible in up to a solution, which you have to do in O of and like 1 second basically. That is 10 to the power 7 iterations almost. So what we can do, if you use the brute force approach, that would take you almost like, yeah, you go through the sum like almost like every time every pre-computed sum would be compared with this pre-computed sum of even and odd, and that would take you around maybe of n square comparisons, right? In worst case, maybe more, right? Let's see. So what my first thought was that as we are checking the sub-array sum, right? We are going about sub-array sum. My first thought when I need a sub-array sum in O of n goes to a intuition, like my intuition around it is pre-computation. To be more specific, prefix sum. If you have used prefix sum before, it is a problem of prefix sum, but not exactly a trivial problem of prefix sum. So what you have to do basically, if let's say what I did essentially what I thought essentially was just I'll make an array where I'll just store odd integers odd integers based strings, like this would be 1, this would be 3, this would be 5, etc. And similarly for even, this would be 2, 4, 6, and etc, etc. And this would be their pre-computed sum, right? So this would be a of 1, this element would be a of 1 plus a of 3, this would be element a of 1 plus a of 3 plus a of 5. You get the idea, right? And similarly for even one, we would do the same for this. But this won't, like after let's say we got our pre-computed array like this and this, what we need to do is find such L and R where both of the pre-computed, how would you find a pre-computed sum between L and R? I hope you know that. If you don't, to find a pre-computed sum between index L and R, we would just do, let's say P was an array of pre-computed sum, P of R minus P of L minus R. Okay, if you don't know pre-computation technique, I'll just tell you what it is. Let's say you have an array, right, from 1 2 3 etc etc, and you have a this is array A, this is pre-computed array P. So this is prefix sum array P, and what you would do here is first element of prefix sum array would be a of I, as it is a of 1, and second would be a of 1 plus a of 2, and you get the idea. So basically a of n equals to a of n minus 1, p of n minus 1 plus a of n, correct? Like any element a of, my bad, p of I equals to p of I minus 1 plus a of I, like adding the previous old prefix sum plus new element of our own array. Like we have this index, like if for example this current index would store the sum up to this index, and we would be adding this element to get our new prefix sum element, right? Like this element plus this, right? So moving forward, we would use prefix sum in our question, but this approach won't work because, like for computing prefix sum of both arrays and making them equal, like for one we would, for odd ones we would compute odd prefix sum and odd array prefix sum, and we would have even array prefix sum, correct? Okay, so just continue. We have odd prefix sum and even prefix. If you do this way, the problem would arise for which L and R, here would you get the same amount of drink, same amount of sum. You cannot compute this in O of n. This won't be possible. It would take you O of n square. So problem still persists. So this is a new way to think. Basically, think in this way. If I just made odd elements as positive and even elements as negative and computed prefix sum array, that would solve my issue, because all I need is a subarray from an array where my sum of odd and even would become equal. So instead of making two arrays and making comparisons in them, I would just maintain a single array with odd numbers would be added as positive and even numbers would be added as negative. How did I build this intuition? So instead of glasses, think of a problem as a bucket, right? In this bucket, let's it's way too big. Wait a sec. Okay, so in this bucket, I'll be pouring down the glasses of Lulia, that is odd glasses, and taking out from it as even glasses her date, right? If Lulia drinks some, let's say X amount, and her date drinks some, let's say Y amount, so I'll just pour in X into the bucket and pour out Y from the bucket, right? Yeah, this makes sense, because we are assigning our odd integers as positive and even as negative. So whenever the odd term comes into, like odd index comes into our array, we will just add it into the bucket, and whenever even term comes into our even term, my bad, even index term comes into our play, so we would just remove it. What does it essentially do? Let's say our bucket was empty at first, right? Our bucket would be empty at first. That would just mean, oh wait a sec, bucket was empty at first. Let's say Lulia drank X and her date drank X. So our prefix sum array would, like our bucket would have 0, and that's what we want exactly, right? We want both of them to drink same amount, like same. This is what we want essentially, right? Let's say bucket after few drinks, after accessing through few elements of the array was filled like this much, right? And Lulia drank this much, okay, like 1 plus 2 plus 10 etc etc. Lulia drank this much, and her date also drank that much in that subarray. So essentially he drank blue part again, and what we are essentially left again was the black part, right? This was at the beginning of the array and this is left at the end too. What this would essentially mean is that in that portion of the sub array, like this was the whole black portion, this was still black portion, this till this thing, right? After that we had a blue portion. In this blue portion the same amount came and same amount was gone, right? This portion would denote that subarray had equal sum, whatever. Subarray of even and odd had equal sum, like same amount came in and same amount was gone. The previous lefted amount didn't really bother us, like it doesn't bother us, right? So this is our intuition. What we would essentially do is just take the elements of array A as this A1 minus A2 plus A3 minus A4 etc etc, and just find prefix sum array of the following, right? This would just give me as P of 1 equals to A of 1, P of 2 equals to A of 1 minus A of 2, P of 3 equals to P of 2 plus A of 3, P of 4 equals to P of 3 minus A of 4. Like as I have told you the general formula for pre-computation. Okay, like I have explained the pre-computation right here. Like this is the general formula. I'll just write it down here again. For pre-computation, you need to use P of I equals to P of I minus 1 plus A of I. Think about it for a while. It would make sense to you if you haven't heard about pre-computation. And this question was essentially the one version of pre-computation, which is like a really nice version because you would see problems like this often. So after this, after finding pre-computation array, whenever if the pre-computation sub-array, if this has some, let's say 10, and any element has, say, let's say 10 here, and this is 10 here, then that would signify that black amount of liquid was present before and black amount of liquid was left after traversing this indices, right? So that would mean the same amount of liquid was poured and same amount of liquid was taken out, right? So if basically to write this formally, if P of any, like I'll just write this logo, any P of I equal to same, then the required subarray exists. Else, or basically this is always true. And one more corner case that most of the people leave many a times, like this one, for example. Okay, I don't have to discuss right here, but I'll just explain to you. So one corner case was that if, like at the start of our question, the bucket had 0 liquid inside it, right? Like inside the bucket there was 0 liquid. Some came in and some came out, right? So even if our prefix, and so what I mean to say is, initially this is prefix array, right? 1. So let's just initialize our 0th index as 0, because at any point if our pre-computation sum or prefix sum becomes 0, that would just essentially mean the same amount of liquid was poured and same amount of liquid was thrown out. That would just mean ki this sub array sum would have existed, and this would print yes. So whenever our P of I, any prefix sum becomes equal, any of the prefix sum element becomes equal, like let's see here, any of the prefix sum elements becomes equal or it becomes 0, then our subarray exists and we would print yes. In any other case except that, we would print no. So we would just look into the code very really quick and I'll demonstrate if you have any issues. So this is my code for the problem. This is my template and this is test cases loop. So next I'm taking the input in array vector, actually taking the input and making a prefix sum array, initializing my P of 0 as A of 0, right? The first element of prefix sum array would be equals to first element of the given array, right? So here I'm initializing it and then I'm computing the prefix sum array, adding the even elements and subtracting the odd elements. Okay, no issue in that because I'm using 0 based indexing. I'm adding even elements and using odd based indexing, so I'm for odd numbers, I'm odd based index, I'm subtracting the numbers. Okay, then I'm creating a map just to check whether any element occurs more than 2 times, 2 or more than 2 times. So the first element of the map stores the element itself and the second element stores the count of the element in our prefix sum, right? If I do not find the element in the map, I'll insert it, make pair, insert this with count of 1. insert prefix sum array element with count of 1, and if I do find the element, I'll increment its count by 1, right? And if my count is greater than or equal to 2, then I'll just make my check value as true. Also, if any of my prefix sum array element is 0, then I'll make my check equal to true, and if my check is true, I'll print yes, and if check is no, I'll print no. I'll post this code in description, you can go through it. Okay, thank you.